One. Today we are going to learn the next measure of central tendency, name is mode, that is positional average. There are two positional averages, first is median and second is mode. In last lecture we have already learned the first positional average, median. Now in today's lecture we are going to learn second positional average, name is mode. First of all we see the definition of mode.
Definition is mode is most repeated observation or observations in a given series of data. Second definition is the observation or observations having maximum frequency called as mode. See case 1 for ungrouped data. What is mode? Mode is most repeated observation or observations in given series of data. See examples. First example is 10, 10, 20, 20, 20, 30. Here we are given only the values of x. That's why it is called as the ungrouped data. So what is the mode? Mode is most repeated observation or observations. Here which value is most repeated? Here the 20 is repeated 3 times. That's why mode is 20. Now the second example is 10, 10, 20, 20, 30. What is mode? Most repeated observation or observations. Here the 10 is repeated 2 times, also 20 is repeated 2 times, but in previous example 10 is repeated 2 times, but 20 is repeated 3 times. What is mode? Most repeated observation. In second example 10 is repeated 2 times, also 20 is repeated 2 times. So mode is 10 and also 20. That means bimodal case. So mode is not unique, but arithmetic mean, geometric mean, harmonic mean is unique. Now the third example is 10, 20, 30 and 40. What is mode? Mode is most repeated observation. Here no any value is repeated. That's why mode does not exist. Now the fourth example is red, blue, black, black, black. The given data is qualitative data. What is mode? Mode is most repeated observation or observations. Here the black is repeated 3 times. That's why mode is black. That means one of the merit of mode is it is calculated for qualitative data. Now see case 2 for group data. What is mode? Mode is the observations or observations having the maximum frequency, that is highest frequency, called as mode. See example, calculate mode for the given data. Here we are given the values of x's along with their frequencies. That means the discrete frequency distribution. So the given data is group data. So what is mode for group data? The observation or observations having maximum frequency. Here which observations having maximum frequency? Here the observation 22.5 having the maximum frequency. So mode is 22.5. Okay, now see the second example, calculate mode. Here we are given the values of x along with their frequencies. What is mode? The observations or observation having maximum frequency. Here observation 3 and 4 having the maximum frequency. Maximum frequency is 15. So here mode is 3 and 4. That means bimodal case. Now the next example is we are given the x values along with their frequency, red, blue, black, brown, white. That means the given data is qualitative data. What is mode? The observations having maximum frequency. Here, which observation having maximum frequency? Here, the black observation having maximum frequency. So mode is black. That means mode is calculated for qualitative data. Now case 3 for continuous data. So how to calculate mode for continuous case? What is mean by continuous case? If we are given the classes along with their frequency, then the data is called as the continuous data. So how to calculate mode in continuous case? Step 1. See the class having the maximum frequency. Step 2. The class having the maximum frequency called as the modal class. And what is the formula for calculating mode? L plus Fm minus F1 divided by 2Fm minus F1 minus F2 into H. What is L? What is Fm? What is F1? What is F2? And what is H? Where L is lower limit of modal class. What is Fm? Fm is the frequency of modal class. What is F1? F1 is the frequency of pre-modal class. What is F2? F2 is the frequency of post-modal class. And what is H? H is the class width. How to calculate class width? Upper limit minus lower limit. But for calculating class width, need the classes is in exclusive form only. Now let's see the example. Calculate mode for following data. Here we are given the data classes along with their frequency. That means the given data is continuous data. So how to calculate mode for this data? First step is see the class having the maximum frequency. Here the class 6 to 8 having the maximum frequency, that is 38. So this class is called as the modal class. So our modal class is 6 to 8. Now what is the formula for calculating mode? Mode is L plus Fm minus F1 divided by 2Fm minus F1 minus F2 into H. First, see what is L. L is lower limit of modal class. What is modal class? 6 to 8. So what is the lower limit of modal class? 6. So L value is 6. Now Fm. What is Fm? Fm is the frequency of modal class. So what is the frequency of modal class? 38. So Fm is 38. Now F1. What is F1? Frequency of pre-modal class. What is the frequency of pre-modal class? 28. So F1 value is 28. Now F2. F2 is the frequency of post-modal class. So what is the frequency of post-modal class is 37. So F2 value is 37. Now last H. H is the class width of modal class. So how to calculate class width? Class width is calculated as upper limit minus lower limit of exclusive classes only. Here the given classes is already in exclusive form because here the upper limit of current class is equal to the lower limit of next class. See 4 equal. So called as the exclusive class. So what is the H value here? What is upper limit of modal class? 8. And what is the lower limit of modal class? 6. So 8 minus 6, that is 2. So H value is 2. Now just plug the value in the formula. What is the L value? 6. What is Fm? 38. F1 28. Then divided by 2 into Fm is 38 minus F1 is 28 and F2 is 37. And what is the value of H? H is 2. Then 6 plus 38 minus 28, that is 10. Then 2 into 38 minus 28 minus 37 is 11. And here H value is 2. Now divide 10 divided by 11. So value is 0.909090. Now multiply 0.909090 into 2. So value is 1.8181. Now add 6 plus 1.8181, that is 7.8181. So value of mode is 7.8181. What is our modal class? 6 to 8. One note is that mode is always lies between modal class. So our mode value is 7.8181. So this 7.8181 lies in modal class. Now see how to calculate mode graphically for continuous series of data. So to find out the mode graphically, draw the histogram. So how to draw histogram we already learned in the topic of graphical representation of data. Let's go through the step. How to calculate mode. So first step is, if the classes are inclusive, then convert it into exclusive. See, our classes is already in exclusive form, so no need to convert it. Okay, now the second step is to calculate the class width for all the classes. So how to calculate class width? Upper limit minus lower limit. So for first class, what is the upper limit? 2. And what is the lower limit? 0. So 2 minus 0, that is 2. For second class, 4 minus 2, that is 2. Then 6 minus 4, that is 2. Then 8 minus 6, that is 2. 10 minus 8, that is 2. Then 12 minus 10, that is 2. Then 14 minus 12, that is 2. And the last 16 minus 14, that is 2. Here the class width for all classes is equal, that is 2. Now take the classes on x-axis and the frequency on y-axis. Now plot the bars on xy plane. For the first class 0 to 2, what is the frequency? 12. So for 0 to 12, 2, it's 12. Then for 2 to 4, it's 22. Then 4 to 6, it's 28. Then 6 to 8, that is 38. Then 8 to 10, that is 37. Then 10 to 12, that is 29. Then 12 to 14, it's 20. And the last 14 to 16 is 14. This is the histogram. Now see how to calculate mode by using the histogram. Here class 6 to 8 having the maximum frequency. So class 6 to 8 is called as the modal class. Before the modal class there is the pre-modal class, that is pre-modal bar, and after the modal class there is the post-modal class. Then how to calculate mode by using the histogram? Join the right corner point of modal bar to the right corner point of pre-modal bar. Similarly, the left corner point of modal bar to the left corner point of post-modal bar. Now we get the two intersecting lines. Okay, from that point of intersection, draw a vertical line on x-axis, and wherever this vertical line meets x-axis, that point is our mode. So here is the mode. Okay, so see, the graph looks like this. So over here mode value is 7.81. So this is the mode concept. Okay, now see merits and demerits of mode. First of all, we see what are the merits of mode. First merit is it is simple to understand and easy to calculate. Okay, now the second is it is calculated by graphically. Yes, it is calculated by graphically using histogram. Now next, it is least affected by extreme observations, because mode is not depends on all observation. That's why it is least affected by extreme observations. Now it is calculated for qualitative data. See, in ungrouped data, suppose my data is red and blue. What is mode? Mode is nothing but the most repeated observations in ungrouped case. So which one is the most repeated here? Red. So my mode is red. That's why mode is calculated for qualitative data. And similarly, mode is calculated for open-end classes also. Now the demerits of mode is not depends on all observation. It just depends on most repeated observations or in group data the observations having the maximum frequency, and in continuous array it just depends on the modal class, pre-modal class and post-modal class. So it is not based on all observation, and if it is not based on all observation then it is not rigidly defined, and if it is not rigidly defined then it is not capable for further mathematical treatment. That means it is not used for the further mathematical calculation. These are the merits and demerits of mode. Now we will see the next lecture is on median. Thank you.